Hi, so if you want to find the inverse of a 3 by 3 matrix, these are the steps that we will consider. The first one, we would have to find the determinant of matrix A. We'll consider the other steps as we go on, but for the first one, let's get to doing that. So we can choose to use any of the rows or the columns. In this case, I'm deciding to use the first column here. And for that one, I've got 1, 4, and 0. So what you generally do is you pick the first element. In this case, it is 1. Cancel its row and cancel its column so that you see the mini matrix that is left. That mini matrix, we are going to have to find its determinant. So I'm just going to put it as -2, 1, and 1, 2. So that for the next step, I can find the determinant. The next element is 4. Now, it's very important to note that each of these elements have got their signages. So the first element is always having a positive. This one is a negative. This one is a positive. So you just interchange the signs as you go on. I'm deciding not to write the other signs because I'm only making use of this column. So since I've chosen 1 and 1 is positive, I have no problem with that at all. And then for the second element, it is -4. So I'm going to put -4 here, cancel the row and cancel its column, so that what I have left will be the minor matrix 2, 3, 1, 2. And so 2, 3, 1, 2. The next element I'm going to choose is a 0. I know when I multiply by 0, everything becomes 0, but I'm still going to pick the mini matrix just to show you what I will have. So if I cancel the row for that and cancel its column, I've got 2, 3, -2, and 1. Okay, so 2, 3, -2, and 1. And all we just need now will be to simplify what we have. Okay, 1 is outside. If I pick the leading diagonal and I take the product, I've got -4. I'm supposed to subtract the product of the other diagonal, and that will give me 1. Okay, then I have got -4 here. And then the leading diagonal has got a product of 4. And if I subtract, I've got a product of 3 from the other diagonal. And the third one will give me a 0. Next, what I want to do is to simplify what I have. So in the first brackets here, I've got -5. And in the second, 4 minus 3 is 1. 1 times -4 will give me -4. So essentially, the determinant is -9. And that's step 1 concluded. I've made a video that explains the determinant of a 3 by 3 matrix. So if you want to learn more, I'll link it up now. You can go ahead and check that out. It explains in detail how you would find the determinant of the matrix A using any row or any column you want. Next, we go to step 2. For step 2, we want to create what we call the matrix of cofactors. I'm going to name it the matrix C. C for cofactors. Now, the matrix C is a matrix that contains all the minors of the elements in matrix A. I will show you what I mean. Now, in this case, we're going to use all the signages that we have, so I'm just going to fill them in. Remember, all you need to do is to interchange the signages. So that is what we have. Now, for the element 1, the minor of that, when you cancel 1 and you cancel the column there, what you have is -2, 1, and 1, 2. So I've got -2, 1, 1, 2. We're going to have to find the determinant of that matrix. For -2, remember that even though that is positive, the signage there says I should consider the minus. So minus. Now if I cancel the row and I cancel the column for that, I've got 4, 1, 0, 2. So I've got 4, 1, 0, 2. And for the element 3, cancel its row, cancel its column, we got 4 - 2 0, 1. And it's positive. So 4 minus 2, 0, 1. Next, we do the middle row. Remember, now that is a minus. So begin by putting a negative sign. Cancel its row, cancel its column. You go 2, 3, 1, 2. So 2, 3, 1, 2. Next, I come to negative 2. The signage there is positive, but 2 itself has its own negative. But that would not change what you have because the signage there is positive. You will not need to include this negative as you are not multiplying the determinant by this factor. Okay, so if I cancel the row and I cancel the column of that, I've got 1, 3, 0, 2, which is what I put down. Hopefully there's no confusion there. And then for here, you got the signage to be negative, so we'll put a minus in front. Cancel its row, cancel its column. You go 1, 2, 0, 1. 1, 2, 0, 1. And then what we have left would be the last row. For the last row, I've got for 0 there. If I cancel the row and I cancel the column right there, I've got 2, 3 minus 2, 1. So I've got 2, 3 minus 2, 1. And then for negative 1 here, because the signage is negative, I cancel the row also and cancel the column. I've got 1, 3, 4, 1. And for 2, I cancel the row, cancel the column. I've got 1, 2, 4, minus 2. Okay, and then we are done with the matrix of cofactors. Okay, next we simplify by finding the determinants of each of these matrices. So for the first one here, the determinant there will be negative 4 minus 1. For this one, there's a negative out, so I'm going to leave it out. And I've got 4 times 2, which is 8, minus 0. For this one, I've got 4 minus 0. Well, I've got 4. Then for this one, I've got a negative outside, and I've got 4 minus 3. For this one, I've got 1 times 2, which is 2, minus 3 times 0, which is 0, so that is 2. For this one, I've got minus 1 times 1, which is 1, 2 times 0, which is 0, so that is minus 1. And then for this, I've got the leading diagonal there, says 2 times 1, which is 2, minus 3 times minus 2, which is minus 6. For this one, there's a negative out, so I've got 1 times 1, which is 1, minus 3 times 4, which is 12. And for this one, I've got negative 2 minus 8. Okay, one more step, and then we're done. We'll be done with step 2. So this will give us negative 5, negative 8, 4, negative 1, 2, negative 1, and then I've got 8, I've got 11, and then negative 10. This here is the matrix of cofactors. The next thing we want to do is to go to step 3, which is to find the transpose of this matrix. The transpose of this matrix is called the adjoint matrix of A. But some people will call it the adjugate of A. That's C transpose. And to find the transpose, all you want to do is to change all the columns onto rows, which means that rows also change to columns. So because you have minus 5, minus 1, minus 8 in the first column, the first row of the transpose will be minus 5, minus 1, and 8. So all I've done is to rewrite this so that it's no longer vertical but now horizontal. For the next row, I'm going to have negative 8 to 11. And then for the last one, I'm going to have 4, negative 1, and negative 10. That concludes the adjoint matrix. And then lastly, what we do is to divide each element in the adjoint matrix by the determinant. So A inverse will be C transpose divided by the determinant. Okay, we already found the determinant to be negative 9. So to complete this, we simply divide each of the elements by minus 9. Minus 1 divided by minus 9. 8 divided by minus 9. Negative 8 divided by negative 9. 2 divided by negative 9. 11 divided by negative 9. 4 divided by negative 9. Minus 1 divided by negative 9. Minus 10 divided by negative 9. If we just simplify that a little bit further, we have this to be 5 over 9, 1 over 9, minus 8 over 9, we have 8 over 9, 2 over 9, minus 11 over 9. This is also negative 2 over 9. Beg your pardon. This one is minus 4 over 9, 1 over 9, and 10 over 9. So here is A inverse. Sometimes it might be good to check if our answers are correct. And one way to do that would be to pick the original matrix and multiply it by its inverse. Now what we expect to get will be the identity matrix. And if we get that, we know that we are correct. The identity matrix behaves almost the same way as 1 behaves when it comes to multiplication of real numbers. We know that if we pick a number and we multiply by its inverse, in this case it's multiplicative inverse, what we get is 1. So if we pick A, that's the matrix A, and we multiply it by its inverse, we expect to get the identity matrix. Okay, so this is what we will just check. It's not a requirement, it just helps you to settle in your mind that what you've done is correct. Okay, so we'll pick the matrix A and try to multiply the matrix A is 1, 2, 3. And A inverse, which we just found, is something that we can just bring down. Okay, now let's begin to multiply. In doing this, I like to take a look only at the column I'm using immediately and to clean out the others so that it does not disturb what I'm explaining. Okay, now that I've hidden all that, what I need to do now is to pick each of these rows and multiply it by this column. Now remember that when I pick the first row and I multiply by this column, what I then have will be the first row here. If I pick the second row and I multiply by this column, I have the second row here. If I pick the third row, multiply by this column, I then have the third row here. That's how it works. Okay, let's begin. So I pick the first one, multiply by 5 over 9. So I have 1 times 5 over 9, which gives us 5/9. Then I'm going to add it to the second one multiplied by the second one, which is 2 times 8/9. That's 16/9. Then the third one, I'm going to multiply by the third element here, which will give me minus 12/9. Now remember, when it comes to multiplication of matrices, I have made a video on that already. I'll link it up right now in case you need to revise that or learn that. It's totally suitable for wherever you are with your math. Okay, we continue. We take the second row and then we multiply by each of these elements. So we have 4 multiplied by 5/9. That gives us 20/9. Then next I have -2 times 8/9. That gives me -16/9. And then next I have 1 multiplied by -4/9. And that gives me -4/9. Next I go to the third row. So I've got 0 multiplied by the first element here. That gives me 0. Don't need to write anything down. I've got 1 multiplied by 8/9. That gives me 8/9. And the last part I've got to multiply by -4/9, and that gives me -8/9. Alright, now I'm done with the first column here. I'm going to go to the second column, and then I will clean up the first column and the last one so that I can keep only the one I want to use in focus. Okay, so for the second one, I pick 1, I multiply it, that's this one. I multiply by 1/9, and that gives me 1/9. And then I pick 2, I multiply by -2/9, that gives me -4/9. And then I pick 3, I multiply by 1/9, that gives me 3/9. Alright, next I go to the second row. I have 4 times 1/9, which is 4/9. I have -2 times -2/9, which gives me another 4/9. And then I have 1 multiplied by 1/9, and that gives me 1/9. Alright, now I go to the last row for that column. I have 0 multiplied by 1/9, that gives me 0. Then I have 1 multiplied by -2/9, that gives me -2/9. And then I have 2 multiplied by 1/9, that gives me 2/9. Now I'm done with the first 2 columns, and I have 1 more column left. I'm going to clean out these first 2 because, again, I want to keep only what is important in focus. Alright. Okay, so the first element here is 1, and then I multiply that by -8/9. That gives me -8/9. The second one is 2. I multiply by -11/9. That gives me -22/9. The third one is 3. 3 times 10/9. That gives me 30/9. Now I go to the second row. For the second row here, I pick 4, multiply by this. That gives me -32/9. And then I pick -2, I multiply by this. That gives me +22/9. Then I pick the last one, which is 1, multiplied by this. It gives me 10/9. And to the last row, because this is tiring already, 1 multiplied by -11/9 will give me -11/9, and then 2 multiplied by 10/9 gives me 20/9. Okay, now we just need to simplify and see what we've got. Alright, so for the first element here, because they all have a denominator of 9, I will not bother myself with that anymore. And I just look at what is up here. So 5 plus 16 is 21. If I take out 12, I get 9. 9/9 will give me 1. Okay, 1 minus 4 here gives me -3. -3 plus 3 gives me 0. I've got 0 there. -8 minus 22 will be -30. If I add it to 30, I get 0, so that also gives me a 0. 20 minus 16 will give me 4. 4 minus 4 gives me a 0. 4 plus 4 is 8. 8 plus 1 is 9. 9 divided by 9 gives me a 1. Minus 32 plus 22 gives me negative 10. Negative 10 plus 10 gives me 0. 8 over 9 minus 8 over 9 gives me 0. Minus 2 plus 2 gives me a 0 also. Then minus 11 plus 20 gives me a 9. 9 divided by 9 gives me a 1. This is the identity element of a 3 by 3 matrix. Okay, now that you see that it gives me what I needed it to give me, we know that we are correct, and our job in finding the inverse of matrix A is complete. Well, this is where I stop this video. I hope to see you in the next one. Bye.